All right, guys, so number one is the only type of question where you're going to really need to know how to use your calculator on your test. So let's begin here. So the number of people in a rock concert auditorium is given by this function r of t, where t is the time in hours. So r is measured in people. That's how many people will be present. And t is measured in time. Okay. Now, part A is asking me to find the average rate of change. Now, as you guys know, the average rate of change, as if you've already looked at your multiple choice study guide already, can be found by doing y2 minus y1 over x2 minus x1. Now, in this case, though, we're not dealing with x and y. We're dealing with r and t. Okay, now the letter that's in the parentheses is like your x. So instead of x2 minus x1 on the bottom, we're going to have t2 minus t1 on the bottom. And my y values are r. So my y2 will be r after I plug in t2. And my y1 value will be r after I plug in t1. So just so you guys know, that's part of the setup there. Now they want us to find it specifically on this interval right here, which means this is my t1 and this is my t2. So if I were to plug in these values, it would look like this. Now just so you guys know, that will be 1 point on your exam, setting that up. You have to write that out, okay? I don't care if you write this, I don't care if you write this, but this you must write, okay? Now the rest of that is going to be done on our calculator, okay? Now on my calculator, we don't get to use the letter r, but we're going to store this function in my calculator under the y1 button. So on my calculator, this is what I'm going to end up typing in. It's going to look like this. Okay, but don't write that on your papers, but that's what we will be typing in on our calculators. So let's go ahead and do that. So turn on your calculator and let's put the function in. I believe it was 500 t cubed. Now instead of t, we're going to be using x. So t to the power of 3 or x to the power of 3. And I believe it was plus 150 t to the 4th power, or in this case, x to the 4th power. Let me make sure I typed that right. Oh, it's minus 150. All right, so I need to go back, and I'm going to change that plus there into a minus. Now, one thing you got to be careful with is this is the minus button right here. There's another button that kind of looks like that on the bottom, but that's a negative, so you don't want to get those mixed up. Those are different. So that's the first thing you got to know how to do is put that into your function, or sorry, your calculator. The next thing that we're going to do is we're going to get out of this screen and go to our home screen by pushing second and quit. Now we get to type in the thing that I told you we're going to type in. We wanted to type in y of 2 minus y of 0 over 2 minus 0. So first of all, let's do how do we get the y? You do not push alpha and y. That's incorrect. You have to push vars, scroll over to y vars, click 1 for function and 1 for y1. And then you're going to put 2 in there. So that's y of 2 minus y of 1, same thing, vars, scroll over, 1 for function, 1 for y1, and then 0. That's the numerator. Okay? Now, I also want to put that over 2 minus 1, but let me just push enter, and that's my numerator. So y2 minus y1 is, I'm sorry, y of 2 minus y of 0 is 1600. But we also need to put that over 2 minus 0. And 2 minus 0 is just 2. And so there's my final answer. So 800 is the outcome there. So we get 800. But we need to include our units. I didn't put that on there, but we do need to include our units. I'll update this guide in a minute because we do need to make sure we include our units. The top number is our values, and we said those are people. the bottom numbers are t values, and we said that was time. So what this is people per hour. So the rate of change, the average rate of change of the number of people is 800 people per hour. And since it's positive, that means it's increasing. So the number of people in this gymnasium for the rock concert, or whatever it is, the auditorium, it's increasing by 800 people every hour, basically. Okay? Let's go ahead and look at the second part of the problem now. The second part is asking us to find r prime of 1.5, and then using the correct units, interpret the problem. So to find r prime of 1.5, we're going to use our calculator. Okay, so let's go ahead and get out of here and go back to our calculator. How do we do r prime of 1.5? Well, we're going to push math. We're going to scroll down to number 8 that says derivative. And different calculators find derivatives in different ways. But if you have the TI-84 like I was recommending, it should look like this. You're going to put an x down here. You want to put your function in there, the r function. But once again, our calculator is not going to let us put r in there. We want to put y in there. And you can't do alpha y. That's just a letter to your calculator. We want the y1 function that we actually stored our thing in there, right? So to get that, we're going to push vars, scroll over, 1 for function, 1 for y1, and it puts y1 in there, and that's the function that I typed in. Now I also want to plug into this thing the time value that they gave me, which was 1.5. And there it is. So that is 1,349.999. Now usually in this class, we want to round to the thousands place. So if we did that, this 6 is going to bump that up to a 10, which bumps 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 that up to a 5. And so we would just say it's 13,500. Okay. In this case, though, I'm sorry, I think I put too many zeros on there, didn't I? So it's 1350. But when we're talking about people, just be aware, you're not going to put decimals if you're talking about people. You can only have a whole number of people. You can't have a fraction number of people. So there's that. Now that's part of our answer, but we want the rest of it now. So that is finding r prime. That would be worth 1 point. The correct units is important also. R prime is an instantaneous rate of change. It has the same units as average rate of change. They're both rates of change. And as we saw in part A, it was people per hour. Now, R is in people, and this number inside the parentheses, the T, that's hours. And so we have a rate, so we know it's going to be something per something, so it's people per hour. Okay? Now, that is another point, getting your units in there. A third point would be the interpretation. And here's the interpretation. In your interpretation, you need 3 things. You need your input units, which is hours, so at hour 1.5. You need your output units, which is people per hour. And then you need to explain the context of your problem. And part of that context is the fact that since this is a positive, it's increasing. The number of people is increasing. If it was negative, then the number of people would be decreasing. So the proper interpretation of this outcome is that at t equals 1.5 hours, there's my input units, the number of people in the auditorium is increasing. That whole sentence there is my context. We're talking about the number of people and whether it's increasing or decreasing. So, part 1, part 2, and then finally part 3. At t equals 1.5 hours, the number of people is in the auditorium is increasing at a rate of 1,350 people per hour. And there's the last part. So we have our three parts: input units, output units, and context. So at t equals 1.5 hours, the number of people in the auditorium is increasing at a rate of 1,350 people per hour. All right, let's go ahead and take a look at number 2. Okay, so another type of FRQ that we looked at in this unit. On this one, I'm telling you that the line given here is tangent to this function at this point. That means that this is my slope, -4. This is my x value, but it's the opposite sign because in the formula it's a minus. So my x value is actually -1, as you can see. And this one here is my y value. All right. Let's go ahead and take a look at part A. Part A is asking me to find h prime of -1. Okay. Well, a derivative is a slope of your tangent line at this point. So what is the slope of my tangent line at -1? Well, it's right there. It's -4. Pretty sweet. That's worth 1 point. So we'll take a look at part B. Now, on this one, they're giving you a function. They want us to find g prime of x, and then they want us to find g prime of -1. So that's going to be a 2-point question. You get 1 point for finding g prime, 1 point for finding g prime of -1. So first of all, g prime of x. Well, here we have a quotient rule. So it's going to be low d high minus high d low. Now, I can't promise you on your test it's going to be a quotient rule. You have to be able to look at this and know, quotient rule, product rule, chain rule. Which one is it? Okay? You have to know how to do the derivatives. It's not necessarily going to look just like this, but it will be some kind of derivative you have to do. Okay? So here we go. Low d high minus high d low. Draw a line and square below. Here we go. All right. At this point, we want to, so this would actually qualify as our answer to this piece, g prime of x. Now I want to find g prime of 1. -1. So what that means is I'm going to be plugging -1 into all these things here. So 4 times -1 squared. I'm going to use brackets now so it doesn't get too ugly and confusing. Move this up a little bit because it's in my way. And then here we're going to have h prime of -1 minus h of 1, -1 I should say. And then finally 8 times -1. Actually, I shouldn't say finally because we have the bottom also, right? That's 4 times -1 squared, and all that is being squared. Okay, so let's take care of some of this easier stuff first. Like here, -1 squared is 1 times 4 is 4. This piece I'm going to leave it alone for now. I'll come back to that in a minute. This piece I'll leave alone. I'll come back to that. This piece I'm going to simplify. That's -8. Down here, let's simplify that. -1 squared is 1 times 4 is 4. Squared is 16. So my bottom is 16. Now let's go ahead and take care of these guys here. H prime of -1. Well, we found that earlier. We found out that that was -4. What's h of -1? Well, here's h. h of x equals y. My x value is -1. My y value is -5. So h of -1 is -5. And now we just get to simplify. Negative 16 minus 40 over 16 is negative 56 over 16. And 8 goes into the top 7 times and the bottom twice, and so negative 7/2 is the last answer. So that's our second point for that particular problem. Let's go ahead and move on to FRQ 3. All right, so the graph below is a graph of y of x. If r of x is equal to this, let me label this graph here as y of x. If r of x is equal to this, then find the equation of the line tangent to r at x equals negative 2. So to find the equation of a tangent line, we need a couple things. We need an x value, we need a y value, and we need an m. Now, the unfortunate thing here is that this y value is not the same thing as this y, okay? We want to be careful not to get those mixed up. This y value really means r of x, okay, the output value for r. Now, x is negative 2. That's nice. So y is r of negative 2. So let's go ahead and plug that in here. So r of negative 2 is equal to y of negative 2 squared plus 3 times negative 2 minus 1. So let's simplify that. 4 minus 6 minus 1 is negative 3. So r of negative 2 is the same thing as y of negative 3. And what that means is, what's the y value on this graph of y over here when x equals negative 3? And that would be right here, and it's 9. So there's my value for r of negative 2. It's 9. Now let's do our m. To find the m, I need to find the derivative of r when x equals negative 2. So to do that, the first thing I need to do is I need to find my derivative of r. This is going to be a chain rule. My outside function is the y function, and my inside is this whole thing here. So y prime, and we'll leave the inside the same, that's the derivative of the outside, multiplied by the derivative of the inside. All right, and now I want to find, after I find the derivative, I want to plug in negative 2. All right, so 4 minus 6 minus 1 is going to be negative 3. And then this piece over here, negative 4 plus 3 is negative 1. Now I need to figure out what is y prime of negative 3. So what this means is I want to know what the slope of the y graph is at x equals negative 3. So what's the slope of this line? Because that's where x equals 3 is at. What's the slope of that line? Well, pick 2 points on that line and just find your rise and run. It's going down 4 and over 2. Down 4 over 2. So rise over run is negative 4 over 2, which is negative 2. So that would be my slope. So the slope of y at negative 3 is negative 2. And then we have this negative 1. And the final answer will be 2. So now that we've got all that stuff, we're ready to write our equation out. I found the x value for the r, I found the y value for the r, and now I found the slope for the r. So here we go. The slope is 2, the x value is negative 2, and the y value is 9. And since this is an FRQ, I would just leave it like that. I wouldn't simplify it. All right, let's go ahead and take a look at number 4. says use the table below to find the equation in the line tangent to the function of h at x equals 1, if h of x is equal to this. Hint, you're going to need to remember something we talked about in class, and that's the fact that ln of 1 is equal to 0. So keep that in mind. Here we go. So if I want to find a tangent line, once again, I need an x, I need a y, and I need an m. So here we go. My x value is given to me as 1. My y value, I can find that by plugging 1 in to the h function. So let's do that. h of 1 is equal to f of ln of 1 times g of 1. And as I mentioned in the directions, ln of 1 is 0, so we can just replace that with 0 now. F of 0 is 1. G of 1 is 2. I'm getting that from the table, and therefore I have 2 as my answer there. So h of 1 is equal to 2. Now I need to find out what is h. To find the slope, I need to know what is h prime of 1. So first of all, I need to take the derivative of this. After that, I'll plug in 1. Now, h, as you guys can hopefully see, has 2 rules in it. That is a chain rule. But because of that, we also have a product rule. So I'm going to call this my A, and I'm going to call that my B, and I'm going to go ahead and apply the product rule of this. A, B, A, B. So A prime, what's the derivative of this? Well, that's going to be a chain rule. I have an outside function here, and I also have an inside function. The derivative of my outside function is going to be pretty simple. It's just f prime, and then we keep the inside the same. The derivative of the inside, well, the derivative of ln is 1 over whatever's here, and in that case, it's an x. B goes here, A goes here, and B prime would be G prime. So there's my derivative. Next, we're going to go ahead and we're going to plug in the 1 that they give us. So h prime of 1 is going to be f prime of ln of 1 times 1 over 1 times g of 1 plus f of ln of 1 times g prime of 1. All right. Now we've already said that ln of 1 is 0, so I'm going to go ahead and replace those with 0 right now. Multiplying by 1 doesn't do anything, so I'm just going to get rid of that. That becomes 0 also. All right, so at this point, the rest of it's pretty simple. We're just going to be reading the table at this point. So let's go ahead and continue. H prime of 1 then is going to be f prime of 0, which we see as 3, multiplied by g of 1, which is 2, plus f of 0, which is 1, multiplied by g prime of 1, which is 0. So this is 6, that's 0, and that's 6. So there's my slope. I found my x, I found my y, I found my slope. We are now ready to go ahead and write out our tangent line. Here we go. Y equals 6 times x minus 1 plus 2. All right, so how would this work? You'd get 1 point here. You'd get 1 point for finding your derivative and 1 point for finding the 6. So that would probably be worth 2 points there, and then 1 point for actually writing out the equation of the tangent line. So that's a hefty problem. That would be like a 4-point problem. Okay? All right. So that being said, I think that does it for us. And good luck to you, and we'll see you in class.